Hey, what's up, guys? Chung here again. So let's take a look at another LeetCode problem this time. Number 205, sorry, number 209, a minimum size subarray sum. So you're given like an array of n positive integers, all right? And you need to find the minimum length of a contiguous subarray for of which the sum is greater than s, right? If there isn't one, return 0 instead. So this is like very typical sliding window problem. Basically, we're gonna have a left and a right pointer, where every time we move the right pointer to the right, right, and then meanwhile we check, and then we'll try to shrink since it's ask us to find the minimum length, So I think there's like this kind of pattern here. So any if the question is asking you to find the minimum length, right? A minimum length of a contiguous subarray, right? Then most likely this problem can be solved with a sliding window technique, right? Basically, we move the uh, we keep moving the right pointer to the right side, and then we're trying to shrink. And then we'll be trying to shrink the left pointer until until this condition is not met, right? Then we find that with the current right pointer as an ending point, what's the minimum length? That's minimum subarray, shortest subarray that still satisfy this current condition, right? Then we just keep moving until we reach the end. That's how we traverse the entire string here, entire array here. Sorry. And the reason being we're using this is because for the sliding windows, the time complexity is O(n). I mean, with traditional brute force way of finding all the substrings, the subarrays, the time will be O n square, right? And with the sliding windows, since in the worst case, the left and right pointers, they will both traversing the entire array, which will be the total time will be n plus n, right? Equals 2n, which will be still the O O(n) time complexity here, right? So, right, enough talking. Let's get right into it. So, uh, and left. So at the beginning, left is 0, right? And then we're gonna have the final answer here is the so since we're going to get the minimum, right? So we initialize this to the max value, right? Max size. And then the right pointer will be we can either use a for loop or a while statement. So I just use a for loop here to keep increasing the right pointer, so I don't have to do a right plus plus in the case of a while loop, right? Enumerate, enumerate, and nums, right? And then mm, actually also for calculating the running sum, right? For calculating the running sum, we can calculate sorry, to calculate the range sum for a specific array, we usually use a running sum, right? Basically, so that we can have a quick way of getting the range sum of a subarray. To do that, we can simply have a pre-processed running subarray here, right? Or in this case, we can simply maintaining a rolling running sum, right? In that case, the time complexity gonna, sorry, the space complexity gonna be uh, O1 in this case, right? Or if we don't care about if we don't care about the space complexity, we can just simply do a pre-sums. I'll just do a pre-sum, so which will make this problem clearer than the rolling running sum. Basically, with the rolling running sum, right? Every time we have a new numbers, we add it to the running sum, and every time we shrink the left side, we decrease the number. We decrease this value from the running sum, and then it will give us the updated range sum. But for the simplicity, I'll just define like a running sub array here. So size will be n. Okay, and at the beginning, everything is actually, you know what? I'll do this. The beginning will be the first element, right, of the 0, and then a for loop, right, for I in range 1 to n, right, and then we simply do a pre-sums append uh, current numbers plus the last running sum, right, pre-sums minus 1. Okay, that's how we pre-calculate all the running sums, right, and then so in this case we have the index here, right? We simply can just calculate the range sum from the left and the right pointer, right? Which will be uh, basically while pre-sum, right? Right uh, uh, minus the pre-sums left, right? Is greater than s, and we'll try to shrink the left pointer, right, to the right, and we're gonna have like a stop point here, I think. So let's and so here we're making sure the current one is the first. The left is the smallest. The left is smallest. The smallest suburb is the farthest we can go, right? As far as we can go, so that we can still satisfy this condition. Satisfy this condition, right? And then every time when we finish doing that, we simply do a minimum, right? To the answer to the right minus left plus 1. Okay. In the end, we simply return the answer once we reach the end. That should just do it. Okay. Hmm. So yeah, I think here, you know, we should only update the answer when this condition has been satisfied, right? Not after the for while loop. We have to do it inside the for loop, right? Because we have to make sure the current answer is one of the correct answer, right? And then yeah, we just move this and then okay, because we need to make sure we need to at least make sure the current condition met the conditions. Otherwise, this subarray is not a valid subarray, right? So let's try that. Uh, mm, okay. Uh, plus 1. Okay. Okay, and actually, there's a few places we need to fix here. I think first, uh, for the pre-sums, right? For the pre-sum, the left and right pointers, and we need a 0 at the beginning because for this, let's say for the whole array, right? For the last element, in order to get the whole string, the whole array's sums, we have to use this like the sum of this position, right? Which will be the whole sum of the entire array. Uh, subtract what? Subtract 0, right? We cannot subtract this first element, right? Because that's not the whole it's not the sum of the whole array. So that's why we need to initialize with a 0 here. And then here from n, right? We get this for n. And so here, like I said, we have to come back here. And since we have these sums here, right? So in order to loop through the correct index here, right? In order uh, find the index, since we don't need these numbers anymore, right? Because we already pre-calculate these numbers with this for loop here. So now we can simply loop through this the pre-sum, right? Which will be the current sum of our of the current uh, position, right? And then we just do uh, yeah, current sum, right? So basically we use the current sum to subtract the left pointer. If it's still satisfied is the greater than s, then we will try to then we know okay, so the current substring is one of our valid answers, right? So we will just update these answers with the right minus left plus 1. That's the length, right? Then we keep moving the left pointers. So let's run it. Hopefully this time it will pass. No, let's see. Okay, I think this thing is we should not do a plus 1 here. Yeah, so this this problem seems like kind of straightforward, but I made so many mistakes about this, about the edge cases here, right? Basically, you know, the reason we will not do a right minus left plus one is because we're using this pre-sums, right? We're using the pre-sum as the as the loop, which means the pre-sum has one more length than the actually numbers here, right? So if we use if we're looping through the numbers here, then we should use a plus one. But since we're doing the pre-sums, we can just use the right and the left because when we reach this number here, right, we are the right plus the right minus left is the actual length of the current nums. So we can just use this, and hopefully this is the last time. Okay, so this thing works. This and submit. Oh, come on. Oh, yeah. Yeah, so this case is the actually if there's nothing in the num here, basically it will never go inside here, right? And then in the end, it will just return the answer here. We can either do a check at the very beginning, or we can do a final check here. Basically, if the num is empty, we can simply do a return answer if smaller than the sys dot max size, right? Else what? Else just zero. Yeah. Who finally, finally it passed. All right. After so many failed submission. Well, okay, quick recap here. So the base idea is simple here. Basically, we just use a pre-sum technique to help us quickly calculate the current range, the current subarray's uh, range sum, right? If the range sum is greater, is satisfy our conditions, then we know, okay, it's one of our answer, and then we'll try to shrink. We'll try to shrink these left pointers to because we're trying to get the minimum, right? The minimum length of a subarray until this condition is not satisfied, right? And then we simply move the right counter, sorry, the right pointer forward until we have traversed all the each element in this array, right? And a little some tricky part here is first, and the presums here, since we're going to use the left and right, we need to have like zero at the beginning, right? And then in the here, that's why when we try to calculate the whole array's sums, we can use this zero, right? Which will be zero in this case. And then since we're using this like uh, we're trying to loop through the pre-sums here, right? That's why when we do the right and minus left, we don't need to do a plus one. Okay. Anyway, long story short, sliding window, pre-sum technique, and then try to shrink the left every time when we have a new right pointer. Cool guys. Hope you guys like this videos, and thank you so much for watching the videos, and see you guys soon. Bye bye.